All right, we will return to Dr. Wintermantel for our last sweet potato whitefly transmitted virus to be discussed today and talk about watermelon chlorotic stunt virus.
It's nice that this is following the squash leaf curl presentation. There will be reasons we get into a little bit that will address that. Watermelon chlorotic stunt virus is a begomovirus and the Gemini viridae. The other two viruses I discussed were in the crinivirus genus. This is a different type of virus, and there are some interesting issues that may be associated with that as I go through the presentation. Watermelon chlorotic stunt virus infects all major cucurbit crops, including watermelon, melon, cucumber, pumpkin, squash, bottle gourd, and a number of cucurbit weeds. The virus was identified first in Yemen in 1986, and like other viruses, spread throughout much of the cucurbit world over time, not only in the Middle East, but also moving to Mexico, where it was found in cactus plants in Mexico and Arizona, as well as some cucurbits in that area. It really wasn't of concern to the southwestern US until 2023, when we saw some odd symptoms on watermelon and melon and caught our attention. And it has now become the most prevalent virus infecting cucurbit crops in the Sonoran Desert region. That's the area of Southern California running into northern Mexico, east of San Diego. Symptoms differ on the different cucurbit crops. Watermelon symptoms are the most severe. Plants develop a mild to bright yellow vein clearing early on, with some mild downward curling of leaves near the vine ends. The symptoms evolve over time into a chlorotic mosaic symptom, as shown on the right. Most of these symptoms are typically found near the ends of the vine early on and then spread into the rest of the plant. Young leaves that develop symptoms may not fully expand, and mosaic symptoms and scarring of fruit may occur as well in severe situations. In melon, the leaves generally produce, again, symptoms occur toward the ends of the vines, but generally occur with kind of a yellow or white interveinal chlorosis. I call it a blotchy mottle pattern, as shown in the photo on the right, taken by John Palumbo when this virus was first found in Arizona in 2023. On squash and pumpkin, symptoms are a little milder. Some kind of a chlorotic mottle on squash, curling of leaves, apical stunting. Cucumber plants, also a little bit of stunting and curling, but it's really much milder on squash and pumpkin than on watermelon and melon. The virus, as I mentioned previously, has been found in several parts of the world, particularly in the Middle East, but has now become a concern in the Western US and Mexico. The area of concern here, let's see if I can turn this on. The area of concern here is this area of southwestern Arizona and southeastern California into Sonora, Mexico. This area is hit hard by watermelon chlorotic stunt and other viruses, including CYSDV and CCYV. Squash vein yellowing virus is also present in that region, although I will point out that virus has not shown vine decline in the western production regions. There was also an identification of watermelon chlorotic stunt virus in Merced County. This was an early identification, and that in a late season field, and that the virus is not established in that region. So I have not highlighted Central California. This other production region here has not yet been infected by watermelon chlorotic stunt virus. The virus is transmitted exclusively by the sweet potato whitefly, Bemisia tabaci, particularly by the biotype B or MEM1. Can also be transmitted by others, I believe, but most of our information is on MEM1. The virus can be acquired and transmitted with short feeding periods of just a few hours, but there is a period of time where the virus has to accumulate and build up within the whitefly, where it moves into the salivary glands and then can be egested as the whitefly feeds into new plants. The virus does not really replicate in the plant, but it does accumulate over time in the plant. It is also not known to be seed transmitted. The pattern of distribution in the field does not correlate with any kind of seed transmission. Whiteflies can transmit watermelon chlorotic stunt virus for life once acquired from an infected source. As with other whitefly transmitted viruses, the larger the population of the whitefly in the field, the more of a concern you have for spread and plants becoming infected early on. The younger the plant, the more severe the symptoms are likely to be. Warmer weather will increase whitefly movement from plant to plant, field to field, and even into some of the weeds. Weeds, as with other viruses, and has been mentioned throughout the session today, are an important part of the epidemiological complex for this virus. They provide a source of overwintering for the virus during non-cucurbit seasons, and many of these plants are actually very good reservoir hosts. As you can see, I've highlighted a few here. I have a much larger list of desert weeds that are hosts of the virus, but these are some that we believe may be of more significant concern. Particularly look here at nettle leaf goosefoot, where you can see that basically 48% of the plants we tested were positive for this virus. London rocket, again, a very good host. And again, look at London rocket. You'll see very few symptoms on a London rocket plant. This plant may or may not be infected. One doesn't know with the virus, but it doesn't show a lot of viral symptoms when it is infected with viruses. So you can't tell what's going on. Most of these weeds will remain symptomless with watermelon chlorotic stunt, much like many of the other viruses. As with other viruses, watermelon chlorotic stunt looks like many of the other viruses that we have. Looks a little different than what we generally see with CYSDV or CCYV or even aphid-borne, but the early model symptoms of those viruses look a lot like the model symptoms you see here in the center of this watermelon chlorotic stunt virus infected melon plant. So it is difficult to look at a plant and know what your causative agent is. It also could have some similarities to other begomal viruses that are not yet in the United States. To address that, we need to have molecular detection systems. These systems allow us to look at multiple targets at the same time. As with other viruses, a PCR system, this is a DNA virus, so a PCR system is effective for detecting this virus, either just plus minus as shown on the left, or a quantitative method. There's also the potential for high throughput sequencing, where we can basically look at everything that's in a plant and find out what's in there. These are all techniques that can be done by a diagnostic lab. The beauty of watermelon chlorotic stunt, as with other begomal viruses, is you can use a different method called rolling circle amplification, which basically taps into the virus's replication process and can be used as a way to get a large chunk of the genome and find out what you have and what it might be related to. Serological methods are also available for detection of watermelon chlorotic stunt and can be useful for measuring the amount of virus or determining whether the plant is infected with the squash blot. Co-infection is a big problem with watermelon chlorotic stunt, unlike some of the other viruses. Many of the viruses we've talked about today will co-infect plants. There'll be mixed infections of 1, 2, sometimes 3, or even 4 viruses. But with those viruses, there often is just more of a cumulative effect of just a little more of a load on the plant because of the virus infection. The situation with watermelon chlorotic stunt virus is quite different. Some nice work done in the early 2000s by Moshe Lapido's program out of Israel demonstrated that watermelon chlorotic stunt virus can have a synergistic interaction with squash leaf curl virus, leading to severe stunting and fruit impacts in melon and also to some degree in other cucurbit crops. The virus is also a problem in watermelon, but this is really a melon dynamic here that we're looking at. As you can see on the top photo with watermelon chlorotic stunt virus alone, you see that kind of blotchy yellow pattern that you see on the leaves. The squash leaf curl symptom, this is actually the same photo that Femi showed in his presentation a few minutes ago. Single infection of squash leaf curl virus. Squash leaf curl was first found in the western United States in Arizona and California. Watermelon chlorotic stunt is a Middle Eastern virus. When you put the two together, you have really severe issues. And just like in Israel, it looks that we are beginning to see some of those symptoms in the southwestern United States. This is a co-infected watermelon plant, or actually these plants, we don't know which plants are fully infected, but looking at the symptoms, I'm fairly certain that these are. We found a number of co-infections in this field. This was work done with Anna Pastrana at UC Extension in Imperial County, working with Bob Gilbertson's lab at UC Davis and myself. And we are seeing this severe stunting, yellowing, leaf crumpling of plants that is very characteristic of a synergistic type of interaction. So this is something we'll need to monitor in the US. We have not seen this before. It's a new concern. To manage watermelon chlorotic stunt, again, like other viruses, manage your weeds. The virus moves into the weed hosts. Keep the weeds away from the field, out of the field, and monitor the weeds near the field as well, because these can be good reservoirs. Whiteflies don't move just a few feet or inches, meters. They move over larger distances. They can move the virus long distances. Manage your plants before you plow down. Again, insecticide treatment of a field is critical. That keeps the whiteflies from moving into other fields and weed populations where they can overwinter. Coordinate with your neighbors if you can. Use reflective mulches, as has been mentioned many times. The white or silver reflective mulches repel the whiteflies very effectively when plants are young before they cover the rows. Agribon row covers can be, again, beneficial for watermelon chlorotic stunt as well, because you're able to keep the plants virus free for longer periods of time. Then you peel back the row covers and treat with insecticide. You can see here in the outer areas here, the plants were pretty severely hit in this research trial, whereas the row cover plants were quite well protected. Transplants need to be monitored for whitefly eggs and nymphs. Regularly test those both before and after in the field. Virus titers may be low again, as with craniviruses, although the virus is a little bit easier to detect earlier. The symptoms develop a little more quickly in watermelon chlorotic stunt than they do with craniviruses. So you will actually be able to detect them a little bit sooner with a watermelon chlorotic stunt infected plant. Again, raise your plants and transplants in the same area you're going to be transplanting them to. There are sources of resistance identified to watermelon chlorotic stunt virus in melon and watermelon. These are being advanced, but we do not believe there's not anything yet available for the American market with regard to watermelon chlorotic stunt resistance. But there is good material and work is in progress by melon breeders. Watermelon chlorotic stunt is, again, one of our newest viruses. We have a new fact sheet on that was released just a few months ago. That's available on the website, as are postcards for watermelon chlorotic stunt. You can find these through the link on the website. Again, thank you for your opportunity. I'm Bill Wintermantel, virologist with USDA out of Salinas, California. Thank you.
All right. Thank you, Dr. Wintermantel.